Hey guys, welcome back to my channel. Today we are going to be talking about object detection. We're going to be looking at what object detection is. Object detection is finding what and where multiple objects are in an image. We're going to take an example of face recognition. When you have your phone and you held it up to your face, how does it know it's you? I mean, it detects these like different features of your face and just pieces it all together. So if you have maybe a mole, like right here, I'm just taking an example. If you have a mole right here, it looks at that and it pieces like you all have different features in your face than other people. So it just looks at all the details and then it can just detect that this is the person's face. Okay, now it's safe for them to log in. An example is that this right here is a cat, and object detection is it puts like a box around it and it detects what it is. It's a cat. But how did it say maybe that this piece of dirt over here is not a cat? Because it detects when we train the image, it detects that the we gave it some ideas on what a cat looks like, maybe pointy ears, maybe a longer tail, and this just does not match the features that we're looking for. Now we're going to look at how object detection works. Um, so it's trained on a CNN model, which is basically the more efficient way of training it, but again, you can train it anyway. But CNN is just a really good model that you can train it on. Then, so we take our image, and in this case, it detects it's a cat. So we're going to give it the cat image, and it trains through a CNN like CNN convolutional neural network. And then it produces this, and it at least needs to have 4 points to define a bounding box. A bounding box is basically this over here. So as you can see, it has 4 points. It has two X's and two Y's, which adds up to four. And there are two ways to define bounding boxes. So X1 and Y1 is the point at the top left corner of the box. So that's like right here. And X2, Y2 is the point in the bottom right. And the 2 points that I just gave are used to mark a corner. And two more points are used to measure the same height and width. So like basically it's just also used in measuring of the cats. So if you leave even a tiny part out, it might get confused. The neural network might get confused that if this is a cat or not. Okay. So some types of object detection. The slide isn't that complicated. I'm just giving you some ideas on different types of object detections. So number one is traffic tracking systems. This is actually really important because as you can see, they have cameras all over which detect, oh, this car is going to go this way, but let's say another car comes here and they can detect the different variations if it might crash or not. But and also if a car is speeding, it can detect its license plate too. So it just detects a zone and keeps eyes on different zones of the road. Um, Sentiment analysis. We did go over this. It's basically facial recognition, but it's kind of detecting your mood. So if you're like, if I have a camera and my face is on it, And if I'm smiling, feeling happy, then it's gonna think that I'm happy. But if I'm feeling like I have a frowny face or just look dull, then it's gonna think that I am sad. Or if I'm angry, and it can get so complicated that it can go into very like depth into emotions, which is really cool. And activity recognition is where right now if I'm sitting down, and the difference between me sitting down and the difference between me standing up, or the difference between me walking and the difference between me running, is just it can tell what position I am in basically. So these are just some kinds of object detection, which is really cool, and these are more common. Okay, now we're going to look at object detection versus image classification. The reason I'm doing this is that lots of people get confused between object detection and image classification because they're both very similar, but they're not the same. So I'm going to take an example saying that image classification is basically, is there a cat in the image? Yes or no? It just says, is there a cat in the image? Is there a human in the image? You answer yes or no. Object detection is where in the image is the cat, and that's the bounding boxes plus labeling. So I put some images here. It's like there's a dog, there is no cat, so it detects less of that. There's no bus, it detects less of that. And there is a plant, but it still detects less because the main focus is the dog. So Um, that's basically what image classification is. It just tells you, is there a dog in the image? Is there a plant in the image? Or is there a cat in the image? Or is there a bus in the image? However, object detection detects what and where the object is. So let's say way in the back, it thinks that this is a person, this is a person, it detects that this is a car, and it detects that this is a bike, and this is a person. So it's detecting where it is and it's labeling and it's giving bounding boxes to make us understand that there actually is a person there. So, yeah. So, popular object detection algorithms, these are really common ones that people use. RCNN, fast RCNN, and fast RCNN. So, it's basically how faster it gets trained. YOLO is it's really, really famous. It stands for you only look once. Um, SSD, single shot multi-box detector. It's in the name detection detector. RetinaNet, I mean, those are pretty popular, but I don't really use that. Transformer-based models, DETR and Dino. This is just an example of some algorithm where this is YOLO. It splits it into grids, and these things over here are called cells. So if you count, it has 7 cells, 1, 2, 3, 4, 5, 6, 7. And over here is also 7 cells. So it's the YOLO algorithm. It splits it into a grid and it sees which one, and it detects like what parts of it are dogs or a bike. So that's really cool. Large vision models for object detection. So, um, large vision models are LMVs, are large-scale deep learning models trained on massive amounts of visual data, often with billions of parameters. Some key traits on large vision models are they're trained on diverse data sets, so they can detect even images, videos, and even words sometimes. And they can generalize multiple tasks. like detection, classification, and etc. But in this case, we're focusing on object detection. Common types of large vision models. So, vision transformers, VIT, this is really, really popular. Um, I'm pretty sure you've heard of it. Multimodal vision language models. This is pretty popular, but not as popular as vision transformers and segmentation models. This is an example right here of how large vision models look like. If you train your model on code, you should see the training loss or the number of whatever you're training it on. And if you have multiple different types of data sets, it's gonna make a key for you and it's going to show you the final results. And that is it for today's presentation. I really hope you understood more about object detection, and I will see you guys in my next video. Bye, guys.